Let's look at implicit differentiation in section 3.8. So let's see how many examples do I have. 1, 2, 3, 4, 5, and 6. And some of them we're going to just find the derivative implicitly. The other ones we're going to plug in the x value and the y value, find the slope of the tangent line. Okay? So those are the two learning objectives. First, we're going to differentiate implicitly. And what that means is we're going to find dy dx without first solving for y. So some equations are not all nice looking, like y equals blah, blah, blah. They're going to be looking like this. They're not solved for y. So you don't really have to solve for y if you use this strategy called implicit differentiation. So I'll show you how to do that, okay? And the second learning objective is, after doing implicit differentiation, we're going to find the slope of the curve at a given point by plugging in the x value and the y value. So that's the little quick introduction of what we are doing. So let's actually get started on example 1 in this video. I may just do one example, okay? So let's differentiate implicitly. Go ahead and take d dx of both sides. Take the derivative of both sides. Okay? Now, the second line, when I write the second line, I'm going to go ahead and separate these two. It's 15xy plus 2. So I'll go ahead and maybe just separate it out as d dx of 15xy plus derivative of 2. And that equals, now look at the right side of the equal sign for me. What is derivative of 0? That's just 0. Similarly, this part is just 0 too. Derivative of a constant is just going to be 0. So are you okay if I say this is the same thing as derivative of 15xy equals 0, right? Now, what we're going to do is we're going to take the derivative of 15xy with respect to x and solve that for dy dx, okay? So this is a product. This is a product. So what I'm going to do is I'm going to use the product rule, okay? I'm going to use the product rule. I see this as 15x times y. It's okay if you want to pull out the 15 to the front, but I'll just do 15x times y, okay? So if I use the product rule, okay, product rule, I'll have to do first times the derivative of the second plus second times the derivative of the first, right? So, okay. The first is what? I have to be very slow at this. Okay. First is 15x. So I'll write down 15x times derivative of the second. What is the derivative of y? Well, that is dy dx. Okay. Keep going with your what's it called rule? What's this rule called? Product rule. Plus sign, and I need the second. The second was just y. I'm gonna write down y times the derivative of the first. Okay, the first term was 15x, so derivative of 15x is just 15, and all that equals 0. I guess one thing that we must note is this. Note that derivative of y with respect to x is simply dy dx. Okay? Make a note over here. Alrighty, what I'm now going to do is I'm going to solve this for dy dx. Okay, now, no more calculus really. All we now need to do is just solve this for dy dx. So I will go ahead and first subtract 15y from both sides. Okay, if I subtract 15y from both sides, wouldn't I get 15x times dy dx equals negative 15y, right? Because it was adding 15y, I can subtract 15y to move that to the other side. Now, if I want dy dx, as you can see, the last thing that I'm going to do is I'm going to divide both sides by 15x. Okay, if I do that, wouldn't this cancel out? And 15 also cancels out. So my answer is dy dx equals negative y over x. And that's how you can implicitly differentiate this equation. It's kind of fun, you guys, I think. But it will definitely be much easier if we do more and more examples. So let me see how long this video was. This was only 5 minutes. So how about I do another one in this very video, okay? I'm going to go ahead and show you number 2 this time, okay? They said differentiate implicitly to find dy dx. So step number 1, take the derivative of both sides with respect to x. If you do that, as you can see, the right side of the equal sign will just turn into 0. The left side, I should be able to separate these. I'll take the derivative of 3x squared first, and I'll subtract that by the derivative of 5y squared. But the variable that we're differentiating with is x, so we have to be a little bit careful over here, okay? So let me go ahead and get started on this. The first part, if you're working with this, derivative of 3x is 3x squared is 6x, isn't it? So that one was easy. Minus, now let's take a look at this part. We have to be very careful. Okay, I have to multiply. If I'm using the extended chain rule here, I will get 5 times 2, right? And get 10 out here. And y is getting now raised to the first power because we have to go down by 1. But now I need to multiply this by the derivative of the inside function, which is y. So I need to multiply this by dy dx. Okay? Now, if you're like, what just happened? Well, let me remind you. How would you take the derivative of this? 5 times, maybe like 5 times u cubed. How would you take the derivative of this? You're going to say 15u squared times the derivative of u, right? This is really just a chain rule here, you guys. Nothing new. And all that is equal to 0. So my job now is to solve this for dy dx. So first thing that I will do is I will subtract 6x from both sides. Minus 6x from both sides. If I do that, I will get negative 10y times dy dx equals negative 6x. Now, if I want dy dx by itself, I'm going to now divide both sides by negative 10y. If I do that, this negative 10y cancels out, and my dy dx, my final answer is, let's go ahead and simplify this negative 6 over negative 10. If you reduce that fraction, wouldn't that be 3 over 5? 3x over 5y. And this is where you can stop. We found the derivative of y with respect to x, and that is 3x divided by 5y. And you don't have to plug in what y is. This is perfectly fine. You can stop right here. I don't know. Is it easy so far? I don't think it's that bad. Maybe I'm going over too fast. If you think I am, then you let me know, because it's only been 8 minutes. And it's not too long. Maybe I do one. Well, you know what? I will stop in this because I just finished the first page. I'll start a brand new video to go over example 3 because it does look a little bit longer. All right, I'll stop this here then.